Assalamualaikum and good evening. My name is Muhammad Shahrul Izzat bin Muhammad Saad and my member is Muhammad Syarifuddin bin Asmadi. So today I'm going to present about assignment for chapter transfer function and block plot for subject advanced electrical circuit. So what is transfer function and block plot? Transfer function of a circuit is the frequency dependent ratio of a phasor output and element voltage or current to phasor input. Plot are semi-log plot of the magnitude in decibels and phase in degrees of a transfer function versus frequency. So there are some factor or combination in a transfer function. The first one is a gain K. The second is a pole or zero at origin. The third is a simple pole, simple pole or simple zero. So the fourth for quadratic pole or quadratic zero. So this is a table for summary of plot straight line magnitude and phase. So here I have a equation of transfer function. So transfer function is 10 times s plus 10 over s square plus 3s. So if you want to convert it to standard form, you just need to substitute s to j omega. So after convert to the standard form, it will be 10 times j omega plus 10 over j omega times j omega plus 3. So what we have to do is to make 10 and 3 to value 1. So we need to 10 times 10, we have 100. So 3, we put the outside. So we have 10 over 3. So we got 33.33. For gain K, 1 plus j omega over 10 is for simple 0. J omega at the denominator for poles at origin. 1 plus j omega over 3 is at origin. So this is a magnitude for all the factors. So the firstly we need to find the value of k. So 20 log 33.33 we got 30.457, and simple 0 we need to identify the value of z1, which is 10. So next we need to identify the value of p1 equal to 3. So here is for phase z1 equal to 10, z1 10, we got 1. 10 times z1, we got 100. So for poles over 10, we got 0 over 3. So 10 we got 30. So I have this is a magnitude plot for that transfer function. So the purple line is for gain, the red line is for poles at origin, the green line is for simple 0. So the blue line is simple poles. So the firstly 20 at frequency 0, we have 20, 20 dB plus 30 dB, we got 50 dB. So the slope will going down until the next corner frequency, which is W equal to omega equal to 3. So there is a negative 20 plus negative 20 plus 20. So the slope will continue going down until the next corner frequency, which is 10. 8.8 omega equal to 10. So we have negative 20 plus negative 20 plus negative 20 plus negative 20 is equal to 0. So that's why the line, the dark line for the red line uh, for poles at origin. So this is how to make magnitude. So we go to phase. So we go to phase diagram. Phase box plot. So the red line is for poles. The red line is poles at origin. The blue line is for the blue line is for simple poles. So the green line is for simple zero. So at omega equal to 0, we have only 90 degree. So we need dark line just follow until the 0.3 at point 0.3. So at 0.3 uh, we only have the 45 degree. So to those, so the slope going down until w equal to 1. So at at omega equal to 1, this is negative 45 plus 45 degree. So that's why the dark line will be straight until 30. So at point 30, we have the green line for simple zero. So the slope will going up until 100, and the dark line straight until 1k and so on. So that's all for me for question bob plot to transfer function to bob plot. So thank you.
Assalamualaikum, and my name is Muhammad Syarifuddin from BEEI to Sokman. Number matrix B08 B082010357. Okay, today I want to share or tell about how to find transfer function from word plot. Okay, first I get the question for the word plot. First of all, we need to find the we need to know the omega constant from the graph from the box plot lah. Okay, as we seen, we have omega constant 2, 20, and 10. Okay, now is the first step. We need to write down the first slope, the first line for the box plot, which is 20 is equal to, we write down the formula 20 log 10k, where we got the 20 from the starting 20. So we get the k is equal to 10. For the second one, the 0 of this from 20 is going up to 40. This means it is positive 20 dB decay. So a zero slope at 20 dB decay at omega 2 is equal to 2, and it is equal to, we write down the formula 1 plus the omega divided by 2. Okay, for rising graph, we just do, the formula is 1 plus j omega divided something. If it is straight line or go to downward, we need to do 1 divided by 1 plus the omega divided by something. Okay, well, and then after that, for a pole or slope, negative 20 dB divided, okay, at omega 20. Okay, second, we look at omega 20, it's going straight line to 100, to the 100, to the 100 omega. So we write down the formula 1 divided by 1 plus j omega divided by 20. Where we get the 20 from the 20 omega constant is starting of the line, straight line. Okay, after that, we find the third for the third line, which means which is 100. 100, a pole of slope negative 20 is going to downward. It's going to down. So it's also a negative from 20 from 40 to 20. It's going down from 10, 40 to 20. So negative slope at omega 100, and we write the formula 1 over by 1 plus j omega plus 100. So we rewrite the transfer function, and we write the standard form for transfer function. We write down first k, and then we write down that I see that for the straight line and then going upward, get the transfer function in numerical method. Then this is denominated method. So we just write down 10 and 1 plus the omega divided by 2, and then divided by we write down the third, the third point, 1 plus the omega divided by 20, and then times 1 plus the omega divided by 100. Okay. After that, we change the standard form into the transfer function. So we get 10 square root of 4 times 2 plus the omega divided by 20 plus the omega times 100 plus the omega. Okay, that's all for today. Thank you.